All right, welcome back to the night class. Today we're starting topic 8, which is quadratic functions. Quadratic functions are a heavy dose of what you'll have to know for your state test. We've already talked a little bit about them. Quadratic functions means the highest exponent will be what? 2. Okay? You're going to have x squareds and anything below that. All right? So, let's get started. Here we go. Lesson 8.1, example 1. All right. It says identify a quadratic parent function. So what is a quadratic parent function and what are its characteristics? So does anybody know the parent function for the quadratics? You just said it. F of x equals x squared. Very good. You can read. Awesome. Okay? It is in your book. All right? So, it is f of x equals x squared. This is what we call the parent graph. So, everything starts here, and then everything that's added to this changes the graph. Okay? And we're talking about translations, dilations, which is stretches and shrinks. Okay? All right? So, here's a little table they've done for us. You know how to do the table. You plug in x's, right? Plug them in, get your y's, in this case f of x's, and there's your points. Okay? Now, notice, what does it make? What kind of shape is that? Y'all know what that's called? A U. It is a U, but we don't call it a U, we call it a parabola. Okay? It is a parabola. All right? Now, the curve is a parabola. I understand you're going to call it a U. Try not to. Okay? Try to use the proper term, parabola. All right, it's making a parabola. Here are my points. I got a negative 2, 4, negative 1, 1, 0, 0, 1, net 1, and 2, 4. Okay, so the vertex, notice, is 0, 0. Okay, the vertex is simply where it stops going up and starts going down, or where it stops going down and starts going up. Okay, in this case, it's stopping going what? Down and then starts going up. Where it's going down, we say that is decreasing, and when it's going up, we say that is increasing. And it's like reading a book. It's always from left to right. Okay? Because I could see why, because I was confused when I first learned. I was like, they're both going up. What are they talking about? Okay? So, no, on the left side, it's going what? Down. Not the arrow's telling you it goes up forever, but it's going from left to right. It's going down. Does everybody see that? Okay? The axis of symmetry. It's the line that cuts your parabola in half. Okay? That's your axis of symmetry. Notice, see how it says x equals 0? You have to have the x equals because the axis of symmetry is a what? It is a line. So it has to have an equation. Okay? So don't just say the axis of symmetry equals 0. No, it's x equals 0. Everybody with me? Okay? So, there it is. See, they even highlighted it and dashed line. Okay? Now, the parabola opens what? Up. Okay? Can anybody tell me why it's opening up?
Because it's not going down. It's positive.
Why is it not going down?
It's positive.
What's positive? You're saying right.
The y is positive. The x squared?
Out in front here is positive x squared. If there was a negative out front, it would go what? It would go down. Okay? Because that would be flipping it over the what? Over the x-axis. We're right back to our transformations. Okay? Everybody good so far? All right, let's look a little more into it. Here we are. It says, how does the value of the leading coefficient a affect the graph of f of x equals ax squared? So, they've taken the parent graph and they added a what? An a. We just talked about this, okay? So, use the slider to graph some functions of the form f of x equals ax squared with different positive a values on the same coordinate grid and compare them. So, here's my little sliding rule here, okay? As a gets bigger, what's happening to my graph. It does get narrower, which means we are vertically stretching it. Because think about it. If A is 2.5, is 2.5 bigger than 1? Yes. So we have taken it, we've held it at the bottom here, and we've stretched it to where it gets narrower. Okay? What happens if A is less than 1?
It gets bigger.
Let's not say fat. Let's say it gets wider. Not that that's better, but all right. So there's 1. All right. There's 1. It's normal. So anything less than 1, a little wider, a little wider. So now it is doing what vertically?
Is this like the one you did where it can't ever be straight?
Correct. What's it doing now?
It's getting wider.
It's getting wider, which means vertically we are what? Shrinking it. Okay? We're pushing it down, shrinking it. Is that making sense? Okay? Everybody good? Here's exactly what we just said. If A is between 0 and 1, then it's going to get wider, vertical shrink. For A greater than 1, it will be narrower, which is a vertical stretch. Any questions? Okay? Like I said, you know most of all this stuff. We're just applying it to quadratics now. Okay? The whole chapter 8 will be quadratics. In fact, I think the whole chapter 9 is quadratics too. But it's fun stuff.
So if we suck at it, we're going to suck at it for a really long time.
A little while, yes.
Oh.
Example 3. Oops. I'm sorry. I missed one. All right. So here. Now look at what happened. What's A?
Negative.
-1. What happened to my parabola?
It went upside down.
It got reflected down. Why? Because the negative is where? On the outside. Okay? If it's inside, it's going to be inside the parentheses and being squared. You got me? Okay? Now, I want you to understand, if it is inside, okay, this doesn't change. Okay? It wouldn't change because if you square a negative x times negative x is positive x squared, right? So if it were on the inside, you would still just get y equals x squared. It does flip, though, but it's flipping over which axis? The y-axis. So if I flip this over this way, does it look any different? No. So it looks the same. Okay? So this one, we're flipping it down because it's on the outside. Okay? Same rules apply, though. If A is bigger than 1, it's getting what? It's stretching. Less than 1, it gets wider. Okay, it is a shrink. All right? So understand, does the negative have anything to do with stretching and shrinking? No. The negative is what's reflecting it. The number in front of the x squared is what shrinks or stretches. Everybody good? Wonderful. How does the sign of the A affect the domain and range? If A is positive, what's my domain going to be?
Negative. Positive and negative.
Let me go back. If A is positive, what's my domain going to be? All real numbers. X can be any number it wants to be. If A is negative, what's my domain going to be? All real numbers. The domain does not change depending on A. Okay? The range, however, if A is positive, the range has to be what? Positive. Greater than or equal to 0. You wouldn't say the range is positive. You'd say the range is Y is greater than or equal to 0. Okay? If A is negative, now my range is less than or equal to 0. Does that make sense? Okay? All because of A. Everybody good? All right. Example 3. Interpret quadratic functions from tables. So, here we go. Over what interval is f of x equals 4x squared increasing? Over what interval is it decreasing? So, in other words, in layman's terms, where is it going up and where is it going down? Okay? So, I'll show our solutions here. As you can see, when x is negative, going towards 0, what's happening to y? It's decreasing. That would be decreasing. So what's the interval? -2, -1 to 0. Then at 1, what happened? It starts increasing. Okay, so from what? When x is what? How do you say when negative numbers? When x is what? Less than 0, it will be decreasing. And when x is greater than 0, it will be increasing. Okay? Now, I'll be honest. I would much rather look at the graph. Okay? Because the graph would show you, hey, it's going down, and then it's going to go up. And you can see, hey, everywhere to the left of 0, it's going down. That's x is less than 0. Everywhere more than 0, it's going up. Okay? Yes, ma'am.
That being said, how often will you put a table on the test for this lesson?
When you're graphing them, you'll make lots of tables. Okay? You'll make lots of tables. We'll get to the graphing part soon. I promise. All right? How about this one? Say the same thing. A function of the form g of x equals ax squared increases over the interval x is less than 0 and decreases over the interval x is greater than 0. What is a possible value for a?
-1.
A is negative. So you could say a is -1, a is -2, a is -3, a is -464.2. It doesn't matter. Okay? They just swapped it, so a must have been what? Negative. Easy. Example 4. We are applying them. Oh, wonderful. Word problems, in other words.
Mine is great now.
The owner of a new dance studio is installing wooden floors in all of the dance rooms. How much should the owner expect to spend on flooring for a square room with 15 side links, 15-foot side links? Okay? So, we have 15 feet square, all right? It's $8.75 per square foot. So, how do you figure out the area here? You say 15 times 15, 225 times how much is it per square foot? So you just multiply all three of these. I'm sure they make it really hard, which they shouldn't, but they usually do. So 8.75 times x squared. Well, what is my x? 15. So it's 8.75 times 15 squared, $1,968.75. Is that what you got in your calculators? Awesome. All right. Same thing. It says, by how much will the cost increase if the side length of the dance floor is increased by 2 feet? Well, we hold on to what we had in part A, but now, we're going to do it again, but then instead of being 15 feet, it's what? 17 feet. So you need to type in your calculator, 8 times 17 squared, and see what you get.
2,312.
2,312 minus, what did we get for the other one? It's in your book. Should be 1,968.75. So what is the
343.25. Yes. Is it 0.5 or 0.75? 7.75. 343.25.
What'd y'all get for the other one?
2,312.
Huh. They didn't get that unless my book's wrong. I'm just going to put 1 in here and check the answer. Yeah, see, they got that. How are they getting that?
Wait, wasn't it 8.75? Instead of 8?
It was 8 point. I'd say 8. I apologize. It was 8.75. That is where the difference is. Yes. 8.75 times 17 squared.
Yeah,
I apologize. I said it wrong. So is that right now?
Yes.
And then you subtract that and you get a total of 560?
Yes.
Okay, wonderful. Everybody good?
Yes.
All right, last example. We're going to be under 20 minutes today. Compare the rate of change. Rate of change. You've seen that word, or those words.
I hate those words.
Don't hate them.
What words?
Okay, rate of change. That's AKA slope. But are these lines? Are these straight lines? No, so they technically don't have a slope, but we can still find the rate of change. Right? It's the same exact way. So they want us to compare, all right, these two, 0.75x squared and 1.5x squared, over the interval 2 to 4. Okay? So you have to do this 4 times. Okay? We're going to plug in 2 to both. All right? Then we're going to plug in 4 to both and get that answer. And then we're going to find the slopes of those. Okay? So I want to write here, here they are. Apparently when you plug in 2
Get 3.
for f of x, the first one, you do get 3. And for the 4, you get 12. Everybody see that? All right? So do that same thing for g of x. So that's the blue one here. When you plug in 2, you get 6. And when you plug in 4, you get what? 24. So there's your 2 points. And now you do the slope formula, even though it's not technically the slope. You got me? It's rate of change. So let's see here. 12 over... Okay, we got all that. Oops, you can't see this, can you? All right. So find the slope. 12 minus 3 over 4 minus 2 would be 9 over 2. So f of x's rate of change is 4.5. G of x, 24 minus 6 over 4 minus 2 is 18 over 2 would be 9. So the rate of change of G is how much more than the rate of change in F?
Twice.
It's twice as much. Okay, so that means it's getting bigger twice as fast. Understand, that's just over that interval though. You got me? That doesn't mean it increases twice as much over the entire thing. It's just from 2 to 4. Everybody understand that? Okay? If it were a line, would it be over the whole thing? Yes. Okay, but it's not a line, it's a parabola. Everybody good? All right. As always, it's not a parabola.
Well,
It's
then
a
spell it.
parabola. All right? So there's your just a little concept summary there. This is all on in your book. So just give it a look. If you forget something, hope this video helps. Have a great day, and as always, stay above the line.